let's start. Quality assurance. So, what do you think of when I say quality assurance?
Testers.
Sorry?
Testers.
Tests? Okay, yeah.
Testers.
Yeah.
Static code analysis.
Yeah, for example. Anything else? Testing will be a separate subject for the next seminar. So we will handle the things about the testing there. But this is more or less overall what we do related to quality assurance in software development. Let's see. Topics. We will look at software quality management, the quality management process, and software measurement. Why quality management is so important, and standards in the quality management process. Reviews and inspections as mechanisms for software quality assurance, and we will look at measurement for assessing software quality. And we will look at software quality assurance in an agile context as well. Is these familiar topics that you have already had on your bachelor studies? Some of them, maybe? Yeah, okay. Much of the theory that we're using for when I'm talking now in quality assurance, we're talking about plan-driven methodologies. So many of the tools and techniques we use for quality assurance are based on what we do in plan-driven methodologies. But I will talk about it in the context of agile methodologies as a summary in the end of the lecture as well. So what tools and what technical methodologies do we use in agile? I will talk about that in the last part of the lecture. So, but first of all, we'll look at the tools and the processes related to quality assurance as a general. Okay. So, quality management, it's ensuring the required level of quality is reached for software, that is. Okay? And how can we manage that? There are three principal concerns. And what we talk about, or we think of, first of all, when we think of quality assurance, maybe is the project level quality assurance. The application of specific quality processes and establishing quality plan for a project. Because that's what you are working on, the actual project. In your team, you're working on the actual project, and then you will be working on quality processes in your project. But you also have an organizational level for quality assurance. Maybe establishing a framework of organizational processes that builds sets the standards for what you should do in your projects, and maybe set standards that ensures quality in projects as general for the entire company. So typically establishing a framework of organizational processes, business processes, and standards that will lead to high quality products. Because from one project you can learn what worked and what didn't work. What did we do right here and what didn't we do right? And maybe those things that we did right could be standardized throughout the organization, so that we follow the same processes at a later stage in another project as well, because we will know that this works. Okay? So that's a standardization process. So you have the organization level, the project level. In the project level, the application of specific quality processes and establishing quality plan for a project is the typical things you're doing. We will see that the actual process of delivering a product itself could be a quality tool. Like in agile methodologies, the process itself is more or less the quality assurance that you have in agile. Okay, quality assurance. Defining, planning, implementing, and reviewing the management processes within a company, and ensure the product is consistently manufactured to required condition. When you start a project, you do requirements elicitation. That means that you establish the requirements based on what your client wants you to do or other stakeholders want you to do in this project. So then you have your requirements. What's the requirements in the project that we are going to do now? How have we formulated the requirements? Or should we formulate the requirements?
Initial requirements.
Yeah, the initial. But I've already done it for GADC. There we use those. Exactly. And that's the requirements and the project description as well. Those are the requirements that you will get in this project. Okay? And what you have to ensure, and what you're going to ensure by doing agile methodologies, is that you are delivering a project according to what the product owner wants you to deliver and the requirements that are set in the user stories. And that's quality. If you deliver a product that is according to those specifications and other specifications that will occur during the sprints that you're going to do, then you have by definition delivered a quality product. There are also other quality attributes that you can measure quality from. We'll come back to that as we go on. But the main thing when you deliver a product is to ensure that that product coheres to the requirements that are set either before you start a project or during the project or during the iterations of the project. Okay, quality planning. This is plan-driven development. Then you actually set up specific documents for your quality plan. What kind of tools are you using? When are you doing actual quality measurement, and so on and so on. So quality planning, it's identifying the quality standards the project needs to comply with, terms in contract, the actual requirements. And a quality plan sets out the desired product qualities and how these are assessed and defines the most significant quality attributes. Typical structure of a quality plan. We'll skip quite rapidly through this. You have a product introduction, a product plan, some process description describing what kind of methodology and so on you're using, the quality goals, risk and risk management. Okay, quality control, that is more related to both agile and plan-driven methodologies. Quality control is confirming that the product has reached the required condition. And the required condition, as I said, was the requirements, the user stories, and the requirements that occur during every iteration. It defines methods of inspection, in-process inspection, and final inspection. Do you know any types of inspections?
Is that code analysis?
Yeah, that's a tool more or less, but I think I'm thinking more of peer review, for example. That's an inspection method. What is peer review?
You review someone else's code?
Yeah, exactly. One of your peers
Yeah.
review your code, or you review a peer's code. You see? So that could be inside the team, for example. If we follow the pull request flow of, like I told you last time, when you're using revision control, maybe the GitHub flow for doing revision control with pull requests, they typically, when you work on a feature, you fork out the repository. You start working on what you want to solve, and then you do a pull request. After a pull request is sent to a repo, one of the administrators or developers on that project reviews your code, and okay, this is acceptable, we merge it into the repo. That's a typical flow with peer review. So inspections is actual inspections of code, inspections of whether or not your GUI functions, and all sorts of things related to that. Inspections and reviews. The review process. We're back to plan-driven again now. There we have pre-review activities. We have the actual review meeting, which we also have in agile methodologies like Scrum. And post-review activities. Program inspections, that's, for example, peer reviews. Team members collaborate to find bugs. Not only bugs, but maybe insecure code, or code that performs badly, or something like that. Code that isn't according to coding standards, for example. That's also part of peer reviews. This is quite cumbersome, but this is the review process. You plan the review. Every team member does an individual preparation for the review. Then you have a review meeting where you discuss what's functioning, what's not functioning. And then you do error correction, of course, and other types of improvements. And you have follow-up checks after that. You can also use inspection checklists if you have that within your company, or if you have some kind of standardized checklist for inspection. Then you can classify your faults. For example, it could be data faults, control faults, or input-output faults. Data faults can, for example, be all program variables initialized before their values are used. Typically, a linter will do this automatically for you. Some of these things can be automated. Have all constants been named? Should the upper bound of arrows be equal or the size of an arrow or size -1, etc., etc. You see. And control faults like, for each conditional statement, is the condition correct, for example. Yeah. Other types of fault classes, for example, interface faults, storage management faults, exception management faults, etc., etc. So that was an inspection checklist. You also have it is possible to ensure quality by having a good process when you develop software as well. The quality of a product is influenced by the quality of the production process, and I think Agile comes as a result of the faults or some of the wrongdoings in the typical plan-driven development methodologies. So Agile is a reaction to this, to ensure a better process, you see? And as I said earlier, that you always have to, within an organization or within a team, you have to be aware that those things that you're doing that you see that works, you should take them with you and use them later. For example, in your process, are there some meetings that you have that works fine and ensures that it is easier to develop and deliver working software? Then you keep these meetings. Are there meetings that more or less is in the way of ensuring quality? You see that these meetings have no intention or something like that, then you get rid of them. Are there any controls or steps in your workflow that ensures that, okay, now we're working in the right direction and we're delivering good software? Keep these steps in your workflow and get rid of all the others. Typically, you define a process, then you develop a product, you assess the product quality, the product quality is okay, maybe you standardize your process, and then you standardize it for your whole organization. In Scrum methodologies, many processes have already been standardized. You should have iterations, they call them sprints. You should have a sprint planning meeting. You should have a sprint retrospective, and so on and so on. It is standardized for you. You see, it's a framework for how to deliver quality software. And this doesn't occur just by chance. This is something that developers have experienced throughout the 90s and the 2000s. And then, okay, someone thought that, okay, these are quite good practices. Let's bring them down to paper and standardize them into, for example, Scrum. Or extreme programming, that is another type of agile methodology. Okay, quality simplistically means that a software product should meet its specification. We already talked about that. What are the challenges related to quality? Customer quality requirements may compromise developer quality requirements. How?
Feature rushing.
Sorry?
Feature rushing.
The rushing features to...
I want this.
Yeah. Before something other reasonable have been developed or something like that.
Yeah, leads to skeleton frameworks and everything.
Yes, yeah, typically. Yeah. That's a good example. Other things? In web GUIs, we typically have designers that works with the GUIs we should work with them simultaneously, but that doesn't always happen. Then there are often quite, what should I say? They often design both interactions and GUI elements that it's quite difficult to implement. And then you have the design then is the specification of how the GUI should be, and that could be it could be compromising how the GUI functions. For example, it could be slow because of some kind of animation that the designer wants. It could be it could compromise the typical analogies that a user is familiar with, like buttons and other GUI elements, and many other things. That is also an example of how customer quality requirements or designer quality requirements can compromise developer quality requirements. QR are difficult to specify unambiguously. Specifications are incomplete and inconsistent, and requirements change. And because of these things, we use processes like, or methodologies like agile methodologies. Requirements change, remember that. Any of you, some of you are already working in companies now, aren't you? Or have working experience. Yeah. You have seen these kind of things. Requirements change all the time. Yeah, constantly. So be aware of that. In a student project, you typically have IT lecturers that knows what they want and specify it quite good. But when you have clients that have either no experience with IT, or you have some IT specialists, for example, that had other special practices than what you have. If you are a web developer and maybe some IT department is asking for a product, then you will have different kind of view on the requirements. Either some things aren't quite clear when you start a project and some new requirements come, or requirements actually change because you see that other solutions are better than those you have implemented. So there are many typical there are many reasons for why the requirements are changing. I see that I myself constantly refactor code because I see that the requirements I set for myself when I developed a product are also constantly changing. Okay, this is a better solution here, maybe. Maybe I need some kind of messaging queue here, or I need my own logger to log errors, and I constantly find these things that I have to either add to the project or refactor code that is already implemented. And that's also requirements that are changing. Okay, quality management and software development. Typically you have a software development process, either in iterations or, as in this example, this could be iterations as well, but quite linear. You can say that maybe D1 is an iteration, D2 is an iteration, and so on and so on. During this course of the project process, You also have an quality management process. Typically in plan-driven methodologies, this goes simultaneously, and you set a plan according to the milestones that you set in your project plan. And in agile methodologies, we typically do this per iteration. We deliver an increment, we do some automated testing on that increment, and okay, the product is validated by those tests, for example. That could be one way of doing quality assurance in agile methodologies. Standards. Standards define the required attributes of a product or process. You can have product standards, and that's characteristics that all software components should exhibit, e.g. a common programming style or an interface style. All the APIs should have this kind of interface, and so on and so on. Process standards, how the software process should be enacted. Scrum is a process standard, for example. Why standards? It's encapsulation of best practices. So it's derived from what other developers and teams have experienced throughout the history. It's a framework for defining the notion of quality, and it provides continuity. In a company, in an organization that works with development, you always have shifting staffs. So you have new developers in, new designers in, and other designers or developers move on to other jobs. So you have to provide some continuity so new staff can understand the organization. And why not standards? Pros and cons. It may not be seen as relevant and up to date by professionals. V3C, have you heard about V3C? That's the World Wide Web consortium that is standardizing HTML, CSS, etc., etc. If you look at HTML5 as a standard, it's nothing innovative with HTML5. Although it featured a lot of new features that you can do in your web browser, but it's not innovative. A standard is never innovative. It's based on best practices, experiences from what you have done in other projects in your history. You see? So standards are not innovation driving. Those are experiences from what innovation has already experienced, what the innovation has given the development community. And this also means that process standards function in the same way. They are best practices, experiences that we've already done. May involve much bureaucratic form filling, information overhead. I won't go into detail about the standards, but type of standards, you have product standards, Java programming style, for example, that's a standard. You can have modeling notation that you use, for example, in UML. Maybe you have some project plan format that you follow. Also process standards, you have design review conduct. How do you do a review? What should you look for? Your version release process, how do we build the software? What kind of versioning format do we do we use, for example, semantic versioning or and so on and so on. So we have different kind of standards there as well. Some examples of standards. These are frameworks: ISO 9000 and 9001 and ISO 9126 and 25000. So these are standard frameworks that is describing general quality principles. I won't go into details there. Okay, software quality attributes. These are typical external attributes that we think of as quality. Safety, security, reliability, understandability, testability, adaptability, etc. These external attributes in itself are not measurable. You can't measure modularity, efficiency in exact numbers. So we have to decompose these into more specific attributes. And that's what we call internal software attributes. We'll come back to that. You will also see that you have quality attributes conflicts. Not possible to optimize for all attributes. Can you see any conflicting quality attributes here in the external attributes?
Maybe complexity and learnability.
Yeah, for example, very good example. Complexity and learnability and actually understandability as well. It's more difficult to learn and use or learn to develop on a complex software than it is on non-complex software.
But you don't optimize to make something more complex.
No, you don't. Good point.
Uh,
So you're trying to lower your complexity. Other examples then?
Security and efficiency.
Yeah. Good example as well. For example, do you have an example of that? Actual example?
For example, log is a very secure logging mechanism. They use a lot of resource compared to non-secure logging mechanism.
And the actual example is using HTTPS instead of HTTP. Then you have some kind of overhead doing the SSL verification and
quite a bit actually.
Huh?
It's quite a bit actually.
Yeah, it is. So you have much more steps for a web browser to do an HTTPS request than an HTTP request. And thus not so efficient. Yeah, good example. Let's see. Sorry. Software measurement. If we want to measure quality in software, we have to derive a numeric value for an attribute of a software project. We can't measure anything without having numbers to measure. And then we use metrics for that. It allows for benchmarking and comparison between techniques. Quality metrics. This is used for measuring software. Quality metric is any type of measurement related to software system or process. It allows the software to be quantified, and it may be used to predict product attributes as well. Examples: you can measure lines of code in a program. You can measure the fog index. You can measure the number of person days required to develop a component. These things are measurable. So what you typically do, you have some internal attributes on the right side here, and you have those external quality attributes that we already talked about. You typically link some of the internal attributes to the external attributes, like depth of inheritance tree will relate to maintainability. And program size in lines of code will relate to reusability. Number of error messages will relate to reliability, etc., etc. So all these metrics are measurable. And then by using a combination of these internal attributes and the metrics for them, you can actually measure maintainability as well. But you're not doing it directly. You're measuring the internal attributes directly and inferring it for the external quality attributes. And typically you have to have some kind of function, either that's a very basic function would be to sum up the scores that you get from each of these internal attributes, and that is, for example, the measurement of maintainability. But typically, you have a little bit more complex functions to derive the value for maintainability or reliability and so on. Okay. Typically, we say that we have dynamic metrics and static metrics. Dynamic metrics assess efficiency and reliability and are typically measured runtime, like response time and number of failures and so on. And you have static metrics, which assess complexity, understandability, and maintainability. But this is a measurement of system representation. What is system representation? Your code is the representation of the system. So it's metrics that analyzes your code and derives measurements based on your coding. Or your overall architecture of your system, your class diagrams, for example, or something like that. Static metrics have an indirect relationship with the quality attributes. There are several examples of metrics: fan in, fan out, length of code, cyclomatic complexity. You can look into these when you go through the slides after the lecture. So these are typical metrics for internal attributes. Okay, another tool for software quality assurance is reviews. A group of people examine the software and documentation. Software and documents may be signed off as approved. Okay, quality assurance in agile methods. Here we typically use these peer reviews. We have sprint retrospectives and sprint reviews. So you have to plan for these things, okay? In your iterations, in your sprints. Maybe get some review, a review step in your workflow, okay? We will talk more about tests in the next seminar, but automated tests can also validate according to the requirements that you have. Maybe you set up a task in Jira and you set up tests that validates that task. okay, it's solved as long as these tests pass. You see? That's an automation of quality assurance. You also have typical practices as test first, TDD. Do you know what TDD is?
Test during development.
Yeah, exactly. And BDD. Anybody knows what that is? Behavior-driven development. It uses TDD as a basis. And test first originally came from extreme programming. TDD was further development of test first. But the main thing is that you write your tests first, and then you write your code, and your code is validated by the test passing. And in agile methods, you have focus on communication and many meeting points. The process itself ensures quality. You have stand-ups every day. You should have stand-ups every day. It's not practically possible in this project to have stand-ups every day, but have as many meeting points as you're able to have without being inefficient. And quality reviews in agile methods, you have a quite informal approach. In Scrum, the review meeting is after each iteration. Sprint review. Extreme programming, there you have pair programming as review. Do you know what pair programming is? You do?
Well, two developers can be developing at the same time, more or less, where one of that's the code and another
Yeah, exactly.
works together with that person and they switch.
So one code and another washes, more or less. That's a simplification, of course. But that's the thing. And then
Cooperative programming.
yeah, exactly. And then you have the review process as you go along, because you have this validation function behind you, the other person that is seeing what you're coding. That's, we have done some pair programming at our company, and it's quite a useful experience actually, because the other programmer knows stuff that you don't know, and you know stuff that he don't know, and maybe you know some practices that are good, and he knows some practices that are good, and then you're automatically reviewing, and you are automatically giving the other person some of your competence. You see, so that's a good way of doing programming. XP also relies on individuals taking the initiative to improve and refactor code. Agile approaches are not usually standards driven, so issues of standards compliance are not usually considered. Any questions to quality assurance? No? I'm a little bit behind schedule, so we'll take a 15-minute break. I'll see if I can get hold of Marish and Simon. Okay. Or do anybody here know where their office is?
If that changed.
Could you go and see whether or not they are?
There, since they have class.
Sorry?
They have class. They have game programming and game design, so they're probably in 255.
255.
Well,
Because did you saw the
That time is scheduled for straight. Yeah, and then Marish.
Does it say is this time edit? No. Is it exchange or something
Yes.
like that?
It's change cap. Calendar.
Okay.
Does it say which room number is it? Yeah.
I don't understand.
I think they use LDAP or something like that, and utilize password.
But then I would have to sign in my student number and my password.
But since they use another one, not the same.
Alright. Yeah, it's just maybe I have to change password that comes from some page.
I don't have it on my
Ja, precis.
account.
Så de här i profile.
Yeah.
But we definitely use LDAP system.
Ja, 254. Checkar det.
So you don't
Tack,
have
tack.
password.
I don't understand anything there.
Yeah.
What?